Hello everyone, this is Dr. Bright Keswani. In today's session, we will discuss about the fundamentals of software engineering, which is a core part of MCA program. Uh, this is the general introduction about the course. The title of the course is Software Engineering Fundamental, and it is having 36 credit course, and this is the internal assessment scheme and external assessment scheme. Internal assessment is of 40 marks, consists of two weekly tests of 5 marks each, two midterm exams of 10 marks each, and two graded assignment consisting of 5 marks each. External assessment consisting of 60 marks, that is end semester examination. Now the prerequisite for this course is a basic understanding about the software and computer programming is needed. This course is not directly related to the uh, coding part. It is a conceptual paper which is related to the basic concept of software engineering. Now these are the learning objectives of this course. Course is not directly related to the coding, but it provides clear understanding about how to prepare documentation, which methodology to be used to develop solution of particular project problem. And throughout this course, the student will also learn first making of program or software is not important, but in today's scenario quality development of software is needed by the industry. So software engineering, learning of software engineering is essential for a computer science student. Secondly, second learning objective is how to make quality software. Software designing of software, development of software is a easy task, but how to make a quality software, how to produce a quality software, it is a major concern of this course. And next is what is software project management means. Quality software quality rises from the software project management. So how to control the activities during the software development, how to monitor the activities during the development is the major concern of software project management. Okay. Uh, Next objective is how to make plan for development and monitoring of software development process. It is very important. And last one is how to ensure the quality of software product. Okay. So these are some learning objectives of this course. This course is related to the engineering uh, uh, because the branch of Master of Computer Application is closely related to the development of softwares. Therefore, course entitled Software Engineering is the core part of this program, and where student will learn various software development methods and models, need of estimation of cost of software project, documentation, quality assurance, and control management, etc. This kind of expertise will help the student a lot when he or she will move to survive in the real world of software development, that is software engineering. So if a student wants to connect with the software development industry, it is essential for him or her to learn the software about the software engineering. The transaction methodology, when we talk about the transaction methodology, the contents will be delivered by through PowerPoint presentation or through group discussion among the students. Uh, uh, Sometimes uh, we will conduct the case, we will adopt the case studies method, and uh, smart classrooms technologies uh, to be adopted by during the lectures. NPTEL lectures will be also provided to the students. Now come to the uh, introductory part of software engineering. First of all, we will discuss about the historical evolution of software engineering. Uh, This PPT is divided into 10 segments. We will discuss in this class, we will discuss about general introduction about software engineering, then software crisis and its reasons, then history of software engineering, software engineering definitions. There are so many definitions of software engineering. We will discuss in this segment various definitions of software engineering given by various scientists and developers. Then essential characteristics of software engineering. We will discuss about manufacturing, how to manufacturing the software, factors in the emergence of software engineering. Then we will discuss about the goals of software engineering, and lastly, principles of software engineering. There are two types of principles of software engineering. First is major principles. Some are additional principles also. We will discuss in this segment, and lastly, we will discuss about elements of software engineering. So, come to the first part of this lecture, that is general introduction. So, as you know, that computer science is still a young field. The first computers were built in the mid 1940s, since when the field was developed tremendously. At present, computer is being used in all sections of our life. Software has also become the key element in the evolution of computer-based systems. Over years, software has evolved from a specified problem-solving tool to an industry in itself. But software has become a limiting uh, factor in the evolution of computer-based system. The size of present software system is increasing tremendously, and we may get an impression of the scale of current software development projects from some examples like NASA Space Shuttle software counts 40 million lines of object code. The IBM OS 360 operating system took 5,000 man years of the development efforts, and the Unix operating systems comprises over uh, 37 lakh lines of source code. So these are some examples which represents the increasing increasing demand or increasing line of codes of the increasing the complexity of the software industry. Okay, so earlier experience in software development has shown that exciting uh, methods and techniques uh, to be adopted by software engineers, and the existing method and technologies for software development were neither sufficient nor up to the mark. Even after 4 decades, the productivity and quality gains in software development have not been reached up to the desired level. As Somerville and Pressman and Arthur said, that nowadays software development of software becomes a crucial activity or very complex activity. More and more new technologies for software development were needed that could control the complexity of the large software systems, so as to deliver the software product well in time and within budget. All the relevant and necessary aspects related to the new designing, new phenomena of software development have been uh, have been discussed in a systematic manner uh, in the following sections of my lecture. So, now we are coming to the next part of this lecture, that is software crisis. And there are so many reasons of software crisis, so we will discuss about the term software crisis. Sometimes the software crisis refers to a set of problems encountered in the development of computer softwares during 1960s. Within this period, the software industry unsuccessfully attempted to build larger and larger software systems by simplifying, scaling up existing development techniques. So as a result, schedule and cost estimates were often grossly inaccurate. Secondly, productivity of programmers could not keep up with demand. And thirdly, poor quality software was produced. So, the phrase software crisis is also refer to encapsulate all the ills of the software and computing system industry. In late 80s and early 90s, the individual software developed like mainly on the probability. The software developed in the 1980s and 90s are uh, portable, having the idea of a reusability. So the complexity involved in porting one application to different platforms, and also the complexity involves in distribution to users were very high. These facts also delayed the projects in search of suitable tools and caused frustration among users to learn different methods. So we can say, in other words, the software crisis is characterized by an inability to develop software on time, first thing, on budget, second thing, and within requirements. Okay, so how do you uh, characterize how do you define the software crisis? Basically, software crisis is the inability to develop software on time, on budget, and within requirements. As a result, the delivered software systems are completely unsatisfactory because they are not as per the user specifications. Secondly, they are extremely late. Thirdly, far over the budget. And lastly, poorly suited for intended user of the system. So, software crisis is a big problem in 1960s, raised in the NATO Science Committee, and uh, it suggested it is characterized by an inability to develop software on time, on budget, and within requirements. Okay. The next, there are some reasons of software crisis. The main reason of software crisis includes uh, lack of communication between software developer and user. Sometimes there is a lack of communication between software developer and the user. Increase in cost of software compared to hardware is the major contributor of software crisis, because software does not wear out. Because hardware, if there is an error present or fault present in the software, you have there is a one simple method to remove that error. You have to remove the entire component. You have to replace the entire component. Okay, and this is the best solution in the case of hardware. But in the software case of software, you cannot remove, you cannot replace this any part of the software, any logic of the software easily. Okay, so uh, increase in the size of software is the major contributor of software crisis. Increased complexity of the problem area is the one of the reason of software crisis. Project management related problem is the uh, one contributor in the software crisis, because management means what? Management means management activity consists of two things. First is monitoring, and second is control. So when the software development itself is a major activity, itself is a crucial activity, so it is very much difficult to control over that activity. It is very much uh, it has become crucial activity it is very much difficult activity to uh, monitor the development process. So project management related problem is there, is the basic reason of software crisis. Lack of understanding of the problem and its environment. Sometimes uh, development team is not aware about the problem and its related environment. So lack of understanding, sometimes lack of understanding about the problem and its environment is the uh, one of the reason of software crisis. High optimistic estimates regarding software development time and cost will be a reason of software crisis. Okay, high optimistic estimates regarding software development time, so you can, and cost, so you can easily you can sorry, you must define, you must calculate the exact time, you must define the exact cost of the proposed software. Then the last and very much important thing is, which is the very much important reason for software crisis, is duplication of efforts due to absence of automation in most of the software development activities. Because software in 1960s, software, there is no reusability concept in the software. So duplication of efforts due to absence of automation in most of the software development activity is the major reason of software crisis. So in nutshell, we can say that software crisis is an inability to develop software on time, on budget, and within requirements. And there are several reasons of for software crisis, like lack of communication between software developer and user, increase in cost of software compared to hardware, increase in size of the software, increased complexity of the problem area, project management related problems, lack of understanding of the problem and its environment, and high optimistic estimates regarding regarding software development time and cost. And lastly, which is very important, that duplication of efforts due to absence of reusability concept, due to absence of automation in most of the software development activities. Okay, so what is the solution of software crisis? Now, software crisis, the solution, the only solution of software crisis is software engineering. To address these all these problems, the discipline of software engineering came into existence. Okay, so this is the reason why software engineering came in existence. What is the software crisis? We discussed uh, in detail about some reasons of the software crisis. Now, this is the historical background of software engineering. So, in as I said earlier, that in 1960s, a NATO study group coined the term software engineering. The premises was uh, building software or engineering software similar to other engineering tasks. So this concept endorsed in 1968 by the NATO Software Engineering Conference, which concluded that software engineering should use the philosophies and theories established by the engineering discipline to solve the software crisis problem. Okay, so uh, in 1968, when the NATO Software Engineering Conference held, some scientists were coined the term software engineering, and they insisted they insisted the community, the development community, to adopt the theories, the formulas, the methods, the tools suggested by the committee to ensure the quality software, to make the software reusable. Okay, so the historical evolution of the software development in the light of varying hardware and software technologies and advancements, are presented in this table. You can see this table, and it is a short historical background of software engineering. Now we'll come to the next part, that is software engineering definition. So there are various definitions coined by software engineering, definitions coined by different studies, different research groups, by different software development organizations and software developers, and sometimes academicians also give some definitions. But we will discuss here in this segment some very prominent software engineering definitions. In the NATO Science Committee in 1967, uh, they coined that software engineering is promoting the establishment of theoretical foundation and practical disciplines for software, similar to those found in the established branches of engineering. On the other hand, Parnas in 1974 find that software engineering is programming under one of the following two conditions. First condition is more than one person is involved in the construction and use of the programs. And secondly, more than one version of the program will be produced. On the other hand, Dennis in 1975 termed that software engineering is the application of principles, skills, and art to design and construction of programs and systems of programs. Boehm suggested that software engineering is the practical application of scientific knowledge in the design and construction of computer programs and the associated documents required to develop, operate, and maintain them. So there are several definitions given by study groups, researcher groups, scientific labs, and software development organizations, software academicians working in the software development field. They given various definitions. Somerville said that software engineering is concerned with building software systems which are large than would normally be tackled by a single individual, uses engineering principles in the development of these systems, and is made up of both technical and non-technical aspects. And as per the IEEE, software engineering is the quantifiable approach to the development or operation and maintenance of the software. So you can see that there are so many uh, definitions. Uh, I elaborated some uh, very prominent definitions of software engineering, which provides you the clear-cut understanding about the purpose of software engineering. Uh, In some other definitions, software engineering is the systematic development, operation, maintenance, and retirement of the software. Software engineering is defined not as a branch of engineering, but rather as a discipline whose aim is to production of quality software that satisfy the user needs and is delivered on time and within budget. So there are so many uh, definitions about the software engineering. Uh, Basically, the aim of software engineering is the production of quality software that is delivered on time, within budget, and that satisfy its requirements. A software which satisfy the user requirement is very important. Development of software through some methodology, through some uh, practices, through some theories, based on some ideas, is very much important. So the uh, uh, supporting tools, association of supporting tools, and association of uh, technologies are also important when we are developing some software. Okay, and these are some prominent definitions. I elaborated some definitions uh, because you know that software development of software is not as simple task nowadays. It it consists of complexity. It consists of many modules. It consists of various theories, various ideas, various algos, and interconnectivity between the modules is essential. So, software engineering is what you do when you have two or more people working on a project. Okay, so it is something different. Programming is something different. Software development is something different from the simple programming. And you are developing a simple program of addition in C. It is something different when you are developing software for an organization, for automation of an organization, or automation of a system. Okay, so software engineering uh, came in existence when you are working in a big software development project. Okay, now uh, there are some essential characteristics of software engineering. So, as I elaborated various definitions of software engineering, some essential characteristics of software engineering field emerged that software engineering concern the construction of large programs. The first characteristic is software engineering concerns the construction of large programs. The central theme of software engineering is mastering key. Third principle is regular cooperation between people and an integral part of programming. Otherwise, you cannot make a software properly. So integration, cooperation with among people and among all part of the modules is essential. The central theme of the software engineering is to produce the quality software is the another thing. The construction of large programs is the third characteristic of software engineering, and the efficiency with which software is developed is of crucial importance. Is the you can uh, you should make a software with you should make a efficient software. You should make a reliable software. You should make a correct software, which makes a software as a quality software. Okay, and this is the aim of software engineering. So the software has to effectively support its user is the last characteristic of a software. When your client is not satisfied, when your user is not satisfied, then what is the purpose of of the development of software? If client is not satisfied, then if the end user is not satisfied, if the client organization is not satisfied, then what is the purpose of software? What is the purpose of building a software? So you have to when you are making softwares, you have to very cautious about these things. You should make a software as a quality software. You should make a software, you should deliver the software in time. You should make software within the budget limits. Okay, and the software engineering is the discipline which provides you, which ensures that the you can make the software, you can prepare the software within the given time limit, within the on budget, and within the requirement. Okay, so these are the essential characteristics of software engineering. Now come to the next part, that is manufacturing software. Manufacturing software can be characterized as a series of steps ranging from concept exploration to final retirement. So we can say that software does not wear out, but software retirement means what? Software uh, came in the stage when you can say this stage as a maintenance stage. Okay, so uh, this series of steps is generally refers to as a software life cycle, which is which is having some steps like requirements, like specification. The third step is designing of software. Fourth step is implementation. Next step is testing. uh, Next step is integration of the module, and last step is maintenance, and finally the retirement of the software. So there are several steps you can see here. Some all steps are related to the development of quality development of software. So we can say it as a software life cycle. So life cycle consists of what? Life cycle consists of requirement phase, requirement analysis phase. Life cycle is consist of second specifications, then design, then testing, then implementation, integration, and maintenance phases. So maintenance is an extremely time consuming and expensive phase. A major aspect of software engineering consists of designing, consisting of developing and using techniques, tools, and practices that will lead to a reduction in maintenance cost. So sometimes uh, the maintenance is a very much costly phase. Maintenance consists of two things. Maintenance is what? Software maintenance is related to the correction in the software. Okay, uh, correction means what? There are two types of maintenances. Basically, adaptive maintenance and corrective maintenance. Adaptive maintenance is related to the environmental changes within the boundaries of the software. Like sometimes client changes his requirement frequently. So adaptive maintenance means uh, as per software development, as per the changing requirement of the environment, changing requirement of the industry. And corrective means to remove the errors from the program, to remove errors from the software is the uh, corrective maintenance. In general, when an error or some fault is introduced during the requirement phase, the result will most likely appear in the specification, design, and code. The earlier an error is detected and corrected, the less costly it becomes. The cost of correcting an error increases significantly as time progresses and the error goes undetected. This directly relates to what has to be done to correct an error. Bohem found that between 60 and 70% of all faults detected in large-scale projects were either specification or design faults. So, in during the 1980s, software maintenance accounted for 60% of the software budget for an information system organization. All this leads us to an understanding of how very important applying sound software in engineering techniques is to not only detecting errors early in the life cycle but also in preventing these errors initially. So when we initially remove the error, we will cost less amount to remove the fault from the system. As suggested by the software lifecycle steps, Solving the large and complex problems presented to software engineering today begins by defining the problems. Solving the correct problem is just as important as solving the problem correctly. Once the requirements are defined, the problem must then be analyzed or broken down into pieces that can be understood and addressed. And this is generally accomplished by using decomposition, in which a larger project is described in terms of a collection of similar problems and their interrelationships. So we can say that decomposition means what? Dividation of the uh, program, dividation of the problem, or simplification. Synthesis is then used to construct the overall solution by taking the solutions to each of the smaller problems and composing an overall solution. So, decomposition and synthesis are the two primary activities in specification and design. So, design activity is majorly concerned with the decomposition process. Okay, only then should this solution be implemented into a particular programming environment and language. Testing and integration should have a direct tie back to requirement specification and designing. So you can ensure the quality through the testing. You can ensure the quality through the proper designing. You can make assurance of the solution to the problem. Software development problem is uh, through the integration, proper integration of the software. Software engineering is about solving problems using computers and programming languages, as I earlier said, that rather than searching and investigating hardware design and implementing an algorithm theory or compiler design, or software engineering focuses on automating problem solution. So when you make your software system as reusable, you can easily solve all the related problems. So problem solutions encompasses not only the algorithm for the solution, but also the environment within which the solution exists, and the other elements of the overall environment system which must interact with the solution include the human factors. Human factors means what? Human factors such as interface designing, such as response time. Okay, so cost overruns, schedule delays, and inadequate testing, especially in uh, uh, safety critical or mission critical softwares, have continued uh, to make the software industry in difficulty. So, in spite of the successes, there is still much room for improvement in the quality of the software produced and processes by which software is produced. So, you can say that software engineering is the complete solution. You can say that software engineering provides a complete solution to the software developer, and development organizations to produce the software, quality software. Okay, now there are some factors in the emergence of software engineering. Uh, the first factor is people developing systems who are consistently wrong in their estimates of time, efforts, and cost. So these are this is the very important factor when people are estimating the development cost, the estimating of the time, efforts, and cost in a wrong manner, or they are not predicting the cost. Secondly, reliability and maintainability were difficult to achieve. It was in earlier in 1960s, before the 1960s, It was very difficult to achieve the reliability and maintainability in the case of software development, and due to this, they are estimating the time, efforts, and cost wrongly. Okay, and the next factor in the emergence of software engineering, why software engineering came in existence. Delivered system frequently did not work. Fixing bugs in delivered software produces more bugs, and increase in size of the software system is the major contributor, major factor, so that the software engineering came into existence. Some other factors are like changes in the ratio of hardware to software cost. Software cost is nowadays is very high in, in respect to the software in compared to the software. Increased cost of software maintenance, introduction of advanced hardware at lower cost. Advancement in software techniques and methodologies is the another factor in the emergence of software engineering. Increased demand of software in almost all areas such as medicine, manufacturing, entertainment, and publishing, and demand for larger and more complex software system is another factor which is uh, contributor in the emergence of software engineering. And lastly, national security and day-to-day operations are highly dependent on computerized systems. So nowadays, computer system uh, working on computer system is must. Development of computer software is must. Uh, uh, we all are online nowadays, so we are dependent. Our day-to-day operations are highly dependent on the computerized systems. We are highly dependent on the uh, tools and techniques of the of the computer system, so of the software. So these all are uh, the factors that in the emergence of software engineering. Now come to the next part, that is the goals of software engineering. There are uh, uh, when we are talking about the general goals of software engineering, we can say that the general goal of software engineering is to produce software that is economic and useful and safe for people. So we can say that the general goal of software engineering is to produce software that is economic and useful and safe for people. But there are some specific goals. There are some main goals. Like first goal is to improve the productivity of the programming and development process. Second is to improve the comprehension of the developed software systems. Third is to control and predicting the cost of software system. Fourth is producing what the customer wants. Last is producing software that satisfy specifications. So it is very much important to produce software which provides the client needs, which fulfill the client needs. Secondly, producing the software what the customer wants. How to predict the cost? It is a very important thing, and which is the main goal of software engineering, to predict the cost of software. Okay, so so that the software uh, built in the given schedule, given time, given uh, budget limits. Okay, and lastly, the main goal is to improve the productivity of the system. Okay, so the we can say that the goal of software engineering is to produce a software system which is reliable, which is efficient, which is having clarity, which is having extendability and reusability. Okay, what is the meaning of reliability of software? Reliability Reliability means reliability is a measure of software ability to respond logically to unexpected conditions and to respond predictability under normal conditions. And what is efficiency? Efficiency is a measure of software's ability to perform its operations in an expedient manner. And what is clarity? Clarity is a measure of software's ability to be understood by those who maintain it. Extendability is a measure of how easily software can have its scope modified and expanded with minimum effect of the software existing external interfaces. Okay, and other things makes also software quality, like documentation, like requirement documents, like specification, like development plans. So these are some factors. These are some uh, factors which makes a software uh, a quality software, and which is the major aim of the software engineering. Okay, now come to the last thing, that these are the what are the references books. So you can consult with, uh, although I elaborated all the topics related to the introduction of software engineering, we will continue it in the next class, uh, and we will discuss about the principles of software engineering, like some major principles, major principles, and additional principles, and aspects of software engineering, elements of software engineering. There are many things which has to be discussed. So we will discuss other things in the next class. These are the reference books. You can refer these books uh, for further information. Okay, now that's all for today. Thank you.